Businesses today stand to gain key business insights through analysis of the data that they generate within the organization and the data available from external sources. As a result, they are making serious investments in building the necessary technological framework to support analysis. A company forays into analytics by first setting up enterprise reporting systems to ensure that data is available for analysis. With much needed information now flowing in from these systems, the company starts exploring areas where analytics can have maximum profitable impact, say human resource or sales. While traditional data analysis methods usually use small samples of data or just one type of data leading to lower return on investment, ROI, big data solutions help the company analyze all data and not just small samples. This analysis would help the organization move from basic exploratory analysis to data-driven predictive analysis. And because of this ability of predictive analysis to solve complex business problems, big data analysis is gaining popularity exponentially. But what is predictive analysis? Predictive analytics is a popular big data analytics that uses big data to determine future outcomes. It cannot predict the future, but can influence the future of the company. Predictive analytics is based on modeling. For instance, you can create a sales analysis model to predict future sales with respect to seasons, festivals, and so on. Finally, the company needs to optimize its results. In other words, it uses analytics to identify an optimal solution to a problem from among various alternatives. This is the domain of prescriptive analytics. In this video, we will explore the various models and approaches to support big data analytics. With big data, business can expand the kind of analysis that can be done, and the insights gained can be used for better strategies and to enhance revenue. Usually, when approaching big data analysis, there are two perspectives: decision-oriented and action-oriented. Decision-oriented analysis is similar to traditional business intelligence. You can look at selective subsets and representations of larger data sources to make business decisions. The decisions could lead to an action or a process change. However, the purpose of the analysis is decision-making. Let's look at decision-oriented analysis in detail. Decision-oriented analysis uses historical and present data to arrive at a decision. For example, supply chain management applications use historical data for decision-oriented analysis. Uses scorecards and dashboards for decision-making. As an example, dashboards and scorecards are used in call centers to analyze call quality. Can be used to alert decision makers on a breach of thresholds. For instance, courier companies use such alerts to alert the management about breach of their service level agreements, SLAs. Takes into account a 360-degree view of data to generate results, thereby considering multiple perspectives. For instance, a sales analysis model can take into account various perspectives such as sales by person, sales by region, sales by product, and so on to analyze the sales of an organization. Typically uses operational data stores, ODS, and data warehouses or data marts to make decisions. Action-oriented analysis is used for rapid response when a pattern emerges or specific kinds of data are detected by computers itself and action is required. Action-oriented analysis applications use various attributes for data selection in a process called segmentation. The segmentation model uses clustering to group data into groups and categories based on common attributes. As an example, this model can be used for mobile user segmentation. Use iterative decisions. The algorithms in action-oriented analysis applications observe the behavior of a user and look for similar data points to make recommendations to other users. For example, online bookstores can recommend books to you based on similar reading habits and purchases of another user. Use programmatic processing, in-process analytics. In these situations, analytics provides better context to decision makers. For example, a call center agent responding to a customer complaint is provided history and analytical profile of the calling person to better respond to a call. Now that you learned about the two perspectives in analytics, let's take a look at the applications for these. You can obtain either packaged or bespoke analytical applications. Some applications, churn prediction, financial fraud detection, anomaly detection models, can be pre-developed and then customized to the needs of specific organizations. These are packaged analytical applications. Some enterprises need analytical applications to be developed from scratch for various purposes. For instance, applications to optimize truck routes or shipment load for carriers, and so on. These models can be developed specifically for such enterprises based on their business processes and business rules. Now that we have discussed about the various models and approaches to support big data analytics, let's see if you can answer this question based on what you've learned so far. If you thought option C is the correct answer, you are right. Iterative decisions to observe user behavior and look for similar data points is one of the popular techniques used in recommendation engines that leverage big data analytics. Here is a recap of the key points covered in this session. Progressive adoption of analytics includes enterprise reporting, exploratory data analysis, predictive modeling, prescriptive analytics. When approaching the analysis of big data, there are two perspectives: decision-oriented and action-oriented. In decision-oriented analysis, you can look at selective subsets and representations of larger data sources to make business decisions. Action-oriented analysis is used for rapid response when a pattern emerges or specific kinds of data are detected and action is required.